Hello, welcome back to our organic chemistry lecture series. Today we're talking about enols and some of the chemistry we can do with enols, particularly acid catalyzed halogenation of enols, right? And we talked a little bit already about this idea about what we can do with the enol. So we're talking about acid catalyzed halogenation of our enols, okay? And so as we do this reaction here, halogenation, we're really going to focus on our normal two elements would be chlorine and bromine. That's what we're going to work with today. So let's look a little bit about this. Let's spend a little time talking about this. So as we talked before, we want to use this, we're going to go through an enol type chemistry. And so we're going to have, we'll say Br2 in this case here, with H3O plus, right? The acid catalyzed part is going to help us make our enol. And then once we make our enol, we're going to react that with our Br2, right? Now remember, when we make our enol is going to be the nucleophile. It's going to attack our electrophile, which would be the Br2, okay? So let's go through the mechanism of this, right? And as we go through this, what we're going to end up finding is we're going to make this compound here, right? And let's go through the mechanism of how we can do that, how we can put this bromine here at this alpha carbon. And as we move through the mechanism, we'll think about this idea like, well, why is the bromine going here and not over there, right? Let's talk about that. So there's some concepts that we'll think about as we go through this mechanism, okay? So let's start with our mechanism. So as we talked about before, we're going to have a carbonyl. It's going to react with what? Our acid catalyzed hydrogen ion. What's going to happen first? We've talked about this before. What? Protonation. Protonation. We have an acid, we should think about protonation. We're going to protonate this. We've protonated our carbonyl, right? Now that our carbonyl is protonated, what do you want to do next, right? As we saw before, oxygen doesn't be positively charged, so we'll move those electrons up. Our resonance, and we get to this species here, right? We get there with that positive charge on that carbon, right? As we talked about before is what? Our water is going to come in. It wants to get its proton back. Going to take a proton, and we're going to generate our enol. Right? We've made our enol. Now that we made our enol, we're ready to do what? We're ready to do our next step, which would be the, second step would be addition of the Br2. Now, as we've done this first step here, make our enol, why did I take the proton on this side rather than taking the proton from that side, right? That's a good question. Why did we do that? Why do we make the double bond here and not over here, right? So what we should do to look at that, let's draw up both structures and maybe we can get more information about that. So let's go back here. Let's erase this. Now, if we look at our enol, particularly that step we got to where we had OH here and a positive charge here. Now, I have two options here. I can pull the proton from here to make a double bond here, or I can make the double bond right here. So let's do both of them. So our water is going to take its proton back. We get our alkene at this position here, or we get our double bond there, right? So the question is, which one of these do you think would be the major product? Which would be the major enol that we form? What would give us our major one, right? And there's a clue to this, right? What's the difference between these? Both have OHs at the same carbon, but look at the difference. We have an alkene on the right side, and we have an alkene on the left side, right? Is there any difference between those two alkenes, right? Any difference there? That kind of gives us a clue of which one would be the major version, right? Has to go back to stability, right? The more stable the product, that's going to be our major product, right? In this case here, we have what? We have this alkene on this side and the alkene on this side. Which one's going to be our more substituted alkene? You know already this one's going to be the more substituted alkene. More substituted alkene. This is less substituted. Right? And we know about this already. We got the more substituted alkene versus the less substituted alkene. And we've talked about this before. Which one's going to be our major product? Which one's always the major product? It's going to be the more substituted alkene, right? The more substituted alkene is, the more stable it's going to be. The more groups around it, the more electron density can be donated to the alkene to keep it more stable. This is going to be our major. More substituted alkene is the major. Going to be our major enol, right? This would be the major enol. This is the one that we're going to see the more often. So if we have an unsubstituted, unsymmetrical ketone, and now as we do these reactions with our enol chemistry, is we're going to form the more substituted alkene is going to be our major enol that we're going to form. That's the one that's going to continue on with the reaction, okay? So we're always going to go looking to form that more substituted enol, right? That more substituted alkene. So this is the one we're going to work with to do our next step in the mechanism to give us our addition of our bromine, okay? Not this one, because this is the less substituted alkene. This would be the minor product. This would be the major product. This is the one we're going to work with, okay? So now that we know which alkene we're going to form, let's look at our enol. So as we finished during our previous steps, we made our enol. Our Br2. And remember, we talked about this already, right? This is going to work as our nucleophile. That means this is going to be then our electrophile. So already you can see what's going to happen, right? We're going to have these electrons here. We're going to attack that bromine, which is going to kick these electrons there, right? So we're going to have this come out here, attack that bromine. We're going to break that bond between the two bromines, right? Get that positive charge there. We know what we can do next. Electrons come back down. And we get to this step here, right? Where we have this oxygen with a positive charge on it. Our last step is going to be what? It's going to be deprotonation. We can use our bromine. You can use bromine to deprotonate that. We also have a little bit of water in the solution as well. You can use that. And we get this form here where we'll be able to put what? Get our carbonyl back, and we now have addition of our bromine here, this addition here, right? So this is one of those first times where we actually have now two functional groups on our molecule. We got a carbonyl, and we have a bromine here, okay? Now we have our bromine here. Now that we have a bromine here, what do you want to do with that bromine? Is there any kind of chemistry you want to do? Well, there's one more reaction that we can do. If I take something like a base, guess what I can do? I can take a base with this, and I can eliminate this to form what? I actually form this molecule here. I can form a alpha beta unsaturated carbonyl, right? Where I have this now this alkene here, right? So this is kind of nice. If I can take a base in here, treat this with this bromine of this alpha carbon here, I can then form an alpha beta unsaturated carbonyl, right? The base for this reaction that generally you use is going to be pyridine. We talked about pyridine a little bit in previous slides. Pyridine is going to be what? It's going to be, it's a weak base, right? It's a weak base. It's not going to be nucleophilic enough to do nucleophilic addition. It's going to just deprotonate the hydrogen here to generate that alkene here and kick off the bromine, okay? Pyridine. So what's nice about this synthetically is now we have a method to put a bromine on here, and if we want to, make an alpha beta unsaturated carbonyl, right? That's going to be useful later on when we look at some other reactions you can do with alpha beta unsaturated carbonyls. So let's look at that. And we can do this with aldehydes as well. So let's take this. I'll take an aldehyde here. Now I can go First step can be Cl2, H3O plus, right? I can do this to make what? I can put a chlorine on there, so now I have a carbonyl, right? Now I have a carbonyl here, and I have a chlorine at this position here. I can do what? I can then add in some purity as my second step. I can make an alpha beta unsaturated aldehyde here, right? And we'll talk a little more about this, at the alpha and the beta carbon, okay? Make this alpha beta unsaturated. So this is a nice method to put our halide here, and then we can use base to make this into an alkene, right? An alpha beta unsaturated carbonyl. We'll talk a little more about this in future lectures about what we can do with that once we make that, okay? So it's new chemistry we can do with enol. This is acid catalyzed version, right? In future slides, we'll look at what can we do when we have under basic conditions with our enol.